So when we're solving equations, we need to know the opposite. Just like if you wrap a present, the opposite of that would be unwrapping the present. And so we're looking at what the opposite is to be able to undo it. The opposite of adding would be subtracting, because that will undo whatever I did. If I added 3 and then subtracted 3, it's like I did nothing. So the opposite of subtracting is adding. An opposite of multiplication is division. And the opposite of division is multiplication. Yeah, too many lines in there. Whenever we're solving or balancing an equation, we want to isolate the variable, which means get it by itself. For example, if we have 3x equals 15, if I want x by itself, and if you can easily pick out what the number is, I still want you to follow the process. That's what's going to make it successful for you throughout your whole life when you're working on equations, or at least your whole school career. So if you know, oh, I know the answer is 5, I still want you to be able to show me that proof by undoing our equation. So we draw a line down an equal sign, and that just helps us. So whatever we do to one side, we're going to do to the other. 3x is 3 times x, so the opposite of multiplication is division. And when I divide, I'm dividing by that 3 because those are going to cancel out. This 3 is going to cancel out with this 3, leaving me with just an x. Whatever I do to one side, I have to do to the other to keep it balanced. And 15 divided by 3 is 5. And I can check it. 3 times 5 equals 15, then I know that I'm right. The real simple ones, it's not as important to check as when we get a little bit more complicated. And that's all we're doing for solving equations. And it gets to the point where hopefully where you're like, oh, it's always the same thing. I always do this, and this, and this. And that's what we're trying to train our brain to do. And it's just like whenever you're solving problems in life, you need to think about what do I have and how do I get to my solution. That's what we're really trying to train our brain to do, more so than just solving equations. I want to go through a couple of these, and then you'll go keep working on the whole sheet and checking the answers. On the first one, drawing that line, the minus 3, I'm going to do the opposite of minus 3. So I'm going to add 3 to both sides so that x equals 9. And my check would just be 9 minus 3. Does it actually equal 6? And if it does, I'm putting a check mark after it. The second one, I don't like these 2 signs in there. Adding a negative is the same as subtracting. So I'm going to rewrite it as x minus 4 equals 8. Because when you're solving equations, the less signs we have in the middle, the easier it's going to be. And you're going to save yourself a lot of time. So in this case, it's a minus 4, or think about it as a negative 4. But to undo that, I need to add 4. My goal is to make that equal to 0. And when I add 4, these cancel out so that those become a 0. And I end up with x equals 12. And again, 12 minus 4, just substituting that 12 back in for the x, equals 8. Again, our goal is really just kind of keeping going with the same stuff. I'm not going to put in the fact that this is equal to 0. Because if I did, for a lot of people, that just gets to be confusing. You can just kind of cross it off, something else to signal that it's not there, or you can just leave it. Whatever is going to work for you. Just like over here, I didn't put in that 0 piece. Looking at that second one, or number 3, 5y, that's just like the one up that we did up here. 5y is the same as 5 times y. I'm going to divide that 5 out. And again, these 2 cancel, leaving me with just a y. That's why I'm dividing it to get my y. So this equals negative 9. And if I do 5 times negative 9, it equals negative 45. So it's just, again, a quick way to check. Number 4, we have y divided by 7. And up above, we said the opposite of dividing is multiplying. So I'm going to multiply both sides by 7. On this side, I get 7y divided by 7, which means that these 2 7s cancel out. Again, that's the only reason why I'm multiplying, is so that I can get those pieces to cancel out. On the other side, I need to put in my calculator 3.5 times 7, and I get 24.5. So y equals 24.5. I always want to have a clean version of whatever I'm doing here at the end. And then over on the side, my check, 24.5 divided by 7 should equal 3.5. As our equations get more complicated, the check becomes more and more important. It's also a great way that you know whether or not you're right before you even submit an answer. I would just wanted to look. Number 10's done for you. You don't have to do anything. It's done. Let's look at number 16. 16's, these three, I don't know why those got on there. These three here are a little tricky. Well, you can skip those if you'd like. These are more we will be working on next time. Actually, not that last one. That one's, right, it's not all three of those. It's just number 16. Just skip 16. Let's look at number 19. 19 is a trickier one that a lot of people struggle with. This is like -1x equals -2. And a lot of people think it's done, but it's not. Because I want that variable to be by itself and not to have that negative in there. So I'm going to divide by a -1. Again, when I divide by that, these -1s cancel out, leaving me with just my x. So that x equals 2. My check is -1 times 2 equals -2. I'm going to have all the answers done. Then you are turning those in.